Dia uno by Mr. Kabongo from the Congo. All right, what are we going to work on today? Today, you're diving into a new function. It's called logarithm. All right, logarithm. So we're going to talk about transformation of logarithm. So what are we going to do here? Let me zoom in. First, we always start with the parent function, right? With the parent function of a logarithm, it goes as follows. So here's a parent function. We're going to write it such as log of x. Now, your next question is, what does it look like? What is a log? If you graph the parent function, what does that look like? Well, the parent function will always start at 1, 0. 1, 0 is right here. Okay, always the parents function will always start at 1, 0. Not only that, it also always will have a vertical asymptote. The vertical asymptote is located at x equals 0, meaning the wall. So you probably is like, well, you're writing too much, Mr. Kabongo. Well, here's the wall. X equals 0 is right here. That's the vertical asymptote for the parent function, and we always be located here. It means when I graph it, it will not cross this green line. So let's graph this. So when you're graphing the parent function of this logarithm, one side goes that direction, and the other side goes the opposite direction, but it will never cross the green line, but it will get closer and closer, but will never cross the green line. All right, so let's do this thing. So let's start with the domain. The domain will be the far left that it will not cross. It will have to be from 0. It will never cross 0. We get closer to 0. That's why I'm using parentheses from 0 to infinity. The range will be started at the bottom of the bottom, negative infinity, to all the way up to positive infinity. The range will always be the case. This will always be the case for the range. The vertical asymptote, which I also call it the wall, in this case for parent function, we just said that it was x equals 0 for the green. Let me use green so we can see that. All right. So let's talk about what the a, b, and everything does here. So the a value, let's use a different color. Let's go back to black. A value, which is the a right here. The a value, if a is greater than 1, then we have a vertical stretch. If a is less than 1, then we have a vertical compression. All right, just remember those. All right, C, when it's positive, we're going to go to which direction? To the left, to the left, to the left, to the left. And if it's negative, to the right, to the right, to the right. Same thing with the value of D. If it's positive, we're going all the way up. If it's negative, all the way down. All right. Cool. Let's put that into work. Oh, right here. Let's do number 1. Remember what I said earlier, that the parent function will always start at 1, 0. Right? That's for the parent function. So we're going to plot that right here. This will kind of just help us graph this. So by observing this, I know it has a minus. So that means this thing went to the right 1 unit. Then it has a +2. So that means down 2. All right. So from this parent function, we need to go right 1 and up 2. So we are right here. All right, so let me get rid of the old one. Boom. All right, so also my wall, where would that be located? My asymptote would be located at the opposite of this. So this is x minus 1, so it's located at x positive 1. Positive 1. So my wall is exactly at 1. So let's go ahead and draw that wall at 1. Boom, 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 boom. There you go. All right, now you can just draw your graph. It goes that direction over her. Let's use red. Goes that direction over here. Little nice little turn that direction. It's not perfect, It's really not perfect. And also, you have your decimals to always double check this stuff too. All right, so we said that the domain here goes from 1 to infinity because it's getting closer to 1, but it would never touch 1 because that's where my asymptote is. The range started at the bottom to infinity. Remember, the range will always be this case for the logarithm. And then we concluded that the vertical asymptote was just the opposite of what was inside, so it's positive 1. Not difficult, was it? Pretty simple, right? All right, let's do another one right here, number 2. All you have to do is pretty simple. So we're going to start with always plot at 1, 0. We always start at 1, 0. And then now we have a negative right here. This negative in the front will stand for reflection over the x-axis, right? And the x-axis is all this line right here. And then after that, we're going to move it left 1, and then we're going to move it down 3. All right, so now the next thing we're going to do is for us to reflect this over the x-axis. So you flip it over this line, over this x-axis right here. If you flip your black point over this red line, it will still land right there where it started. All right, now you move it 1 time to the left. 1 time will be here. And then 3 times down, 1, 2, 3. It'll be right here. That's the new point, right? So let's go with green. That's the new point right here. Now let's not forget we're going to draw a vertical asymptote. A vertical asymptote is located at the opposite of this number, -1, like my wall. So -1 is right here. So there goes my wall. Now we can go ahead and graph our graph. So it goes upward, and this one goes this way, at least somewhere close to it. That's it. So that domain goes from the far left is -1 to infinity. Sorry for my random infinity here. And the range is always started at the bottom. Now we're here, infinity. And then we concluded that our horizontal asymptote, our vertical asymptote was -1. That's it, people. You got the